Amy is a junior full-stack developer who recently joined the team. As a native English speaker, she communicates naturally and casually, using contractions, colloquial expressions, and follow-up questions without hesitation. Alex is a senior machine learning engineer with deep expertise in MLOps. He is from Korea and speaks English as a second language. He is highly competent and articulate, but his English tends to sound formal and textbook-like, grammatically correct yet a little stiff. Throughout this dialogue, look for the phrases marked non-native cadence in Alex's lines and compare them with the native cadence versions right below. Noticing the difference is the first step to sounding more natural.
Hey, Alex, do you have a few minutes? I've been hearing the word MLOps a lot lately, and I honestly have no idea what it means. Can you explain it to me?
Of course, Amy. I am always happy to explain. MLOps is something I work with every day, so I will try to make it clear for you.
Of course, I'm always happy to help. I work with MLOps every day, so let me break it down for you.
So, what exactly is MLOps?
MLOps stands for Machine Learning Operations. You know DevOps, right? The concept is very similar. DevOps helps software engineers build, test, and deploy application in a reliable and fast manner. MLOps does the same thing, but it is specifically for machine learning models.
MLOps stands for Machine Learning Operations. You know DevOps, right? It's basically the same idea. DevOps helps engineers build, test, and ship apps reliably and quickly. MLOps does the same, but it's built specifically for ML models.
Okay, so it's like DevOps but for ML models. That makes sense. But wait, isn't a model just a file? Why does it need all that operational stuff?
That is a good question. A model is not just a static file. It needs to be trained with data, evaluated, deployed, and then monitored in production. The data changes over time, so the model can become less accurate. We call this model drift. MLOps gives us the tools and processes to handle all of that in a repeatable and automated way.
Great question. A model isn't just a static file. It needs to be trained on data, evaluated, deployed, and then monitored in production. And since data changes over time, the model can start losing accuracy. We call that model drift. MLOps gives us the tools to handle all of that automatically and repeatably.
Got it. So, how is MLOps different from DevOps? And what about GitOps? I keep hearing that one too.
They are related, but they are different from each other. DevOps is the general practice of automating software delivery, building, testing, and deploying code. GitOps is a specific approach where everything is defined in Git, and any change to the system is made by updating Git repositories.
They're related but distinct. DevOps is the general practice of automating software delivery, building, testing, shipping code. GitOps is a specific pattern where everything is defined in Git, and any system change goes through a Git update.
Okay, so GitOps is kind of a pattern inside DevOps?
Yes, exactly. MLOps borrows ideas from both, but it also adds things that are specific to machine learning. For example, we need to do tracking of experiments, which model architecture we tried, what hyperparameters we used, and what the accuracy result was. We also need to do versioning of datasets, not just code. And we need pipelines that can automatically retrain model when the data changes.
Exactly. MLOps borrows from both, but layers on things that are unique to ML. For example, we track experiments on which architecture we tried, what hyperparameters we used, what accuracy we got. We also version datasets, not just code, and we have pipelines that can automatically retrain models when the data shifts.
So MLOps has to deal with both the code side and the data side.
Yes, that is one of the biggest differences. In regular DevOps, the data is mostly static, but in MLOps, the data is always changing, and the quality of the model depends on the quality of the data. So data management is a very important concern.
Exactly, and that's one of the biggest differences. In regular DevOps, data is mostly static, but in MLOps, data is always evolving, and your model's quality is only as good as your data. So data management is a first-class concern.
That's really interesting. So, who actually uses an MLOps platform day to day? Like, who benefits from it?
Mainly data scientists and machine learning engineers. Data scientists spend most of their time building and improving model. They experiment with different algorithms, adjust the parameters, and try to achieve the best possible performance. Without MLOps, they must do many manual steps, running experiments on their personal computer, copying model files, and writing their own scripts to deploy things. This process is difficult to manage and hard to reproduce.
Mainly data scientists and ML engineers. Data scientists are focused on building and improving models. They run experiments with different algorithms, tweak parameters, and try to squeeze out the best performance. Without MLOps, they're stuck doing a ton of manual work, running experiments on their laptop, shuffling files around, writing one-off scripts to deploy things. It's a mess and nearly impossible to reproduce.
I can imagine. That sounds really painful.
With an MLOps platform, they can automatically track every experiment, compare the results, register the best model, and trigger a deployment pipeline, all without doing it by hand. So they can concentrate on the actual machine learning work instead of the operations part.
With an MLOps platform, all of that gets automated. Every experiment tracked, results compared, best model registered, deployment kicked off. They can just focus on the actual ML work and not get bogged down in ops.
And what about ML engineers like you?
ML engineers are responsible for building and maintaining the pipelines and platforms. We make sure the training pipelines are working well, the models are deployed in the correct way, and the monitoring is set up properly. MLOps gives us standardized tools and workflows, so we do not need to build everything from zero for each new project.
ML engineers own the pipelines and platforms. We make sure training pipelines are stable, models are deployed correctly, and monitoring is in place. MLOps gives us standardized tools so we don't have to reinvent the wheel for every new project.
So, what are the main pieces that make up an MLOps platform? Like, what does it actually consist of?
There are 5 core components. I will explain each one. First, there is an experiment tracking system. This system records every training run, the parameters, the metrics, and the model artifacts. Tools such as MLflow or weights and biases are popular choices for this. Second, there is a model registry. This is like a central storage place where you keep version models. You can set the status of a model to staging or production so that all team members know which version is currently being used. Third, there are training pipelines. These are automated workflows that take raw data, process it, train the model, and evaluate it. Tools such as Kubeflow pipelines or Airflow are used to manage these. Fourth, there is a model serving layer. This is the place where the trained model is deployed as an API so that other applications can send requests to it. Tools such as Seldon, Kserver, or FastAPI are used for this purpose. And fifth, there is monitoring. After the model is deployed, we track its performance over time. If the accuracy becomes lower than a threshold value, we receive an alert and we may need to retrain the model.
5 core components. Let me walk you through them. First is experiment tracking. This records every training run, parameters, metrics, model artifacts. Tools like MLflow or weights and biases are popular for this. Second is a model registry, so basically a central hub for versioned models. You can tag a model as staging or production, so the whole team knows what's live. Third are training pipelines, automated workflows that take raw data, process it, train the model, and evaluate it. Tools like Kubeflow pipelines or Airflow handle this. Fourth is a model serving layer, where the trained model gets deployed as an API so other apps can call it. Tools like Seldon, Kserve, or FastAPI are common here. And fifth is monitoring. Once the model's live, we keep tabs on its performance. If accuracy dips below a threshold, we get an alert and might need to retrain.
That's a lot of moving parts. So the platform basically stitches all of these together?
Yes, that is correct. The goal is to have one integrated system where a data scientist can move from the experiment stage all the way to production with a consistent and automated process.
Exactly. The goal is one integrated system where a data scientist can go from experiment to production with a consistent, automated flow.
I noticed you said Kubernetes a few times. Why does MLOps need to run on Kubernetes specifically?
It does not have to be on Kubernetes, but Kubernetes is the best choice for most teams. Let me explain the reasons. Training a machine learning model requires a large amount of compute resources. Sometimes many CPUs, sometimes GPUs, and a large amount of memory. Kubernetes is very good at managing these resources across a cluster of machines. You can run many training jobs at the same time, and Kubernetes will schedule them in an efficient way.
It doesn't have to be, but Kubernetes is the best fit for most teams. Here's why. Training an ML model takes a ton of compute, CPUs, GPUs, a lot of memory. Kubernetes is great at managing those resources across a cluster. You can run many training jobs in parallel, and Kubernetes handles the scheduling efficiently.
Oh, so it's about resource management?
That is one reason. Another important reason is scalability. When a model receives a large number of requests, Kubernetes can automatically increase or decrease the number of serving replicas depending on the traffic load. It is very difficult to do this kind of thing manually.
That's one big reason. Another is scalability. When a model gets hit with a lot of requests, Kubernetes can automatically scale the serving replicas up or down. Doing that manually would be a nightmare.
That makes sense. What else?
Kubernetes also provides portability. We can run the same MLOps platform on a local cluster, on AWS, on Google Cloud, or on any other cloud provider. We will not be dependent on one specific vendor. Also, tools like Kubeflow are designed to work natively on Kubernetes, so they integrate very well.
Kubernetes also gives us portability. We can run the same MLOps platform on a local cluster, on AWS, on GCP, wherever. We're not locked into any one vendor. And tools like Kubeflow are built natively on Kubernetes, so the integration is seamless.
And I guess reliability is part of it too. Like if one node goes down, Kubernetes handles it?
Yes, that is also correct. Kubernetes has self-healing capabilities. If a training pod stops working, it will be automatically restarted. This is very important for training jobs that may require many hours or even several days to complete.
Yep, Kubernetes has self-healing built in. If a training pod crashes, it gets restarted automatically. That's a big deal for long training jobs that can run for hours or even days.
Wow, okay. I feel like I actually understand MLOps now. It's a whole ecosystem for making machine learning production ready, and Kubernetes is the foundation that makes it scalable and reliable.
That is a very good summary, Amy. You are a quick learner.
That's a great summary, Amy. You pick things up fast.
I had a great teacher. Thanks, Alex.
No problem. Please let me know if you have any more questions.
Anytime. Feel free to ask if anything else comes up.